also offers further resources for more information. My co-presenter is Lisa Willard with the SD University. First, I will begin with providing general introduction, followed by explaining. Let's take a look at the agendas, followed by introducing BIM concept. After that, I will address how building information modeling, or BIM in short, enhances the workflow with structural engineering practice. And Lisa will address interoperability, legal and contractual issues. Okay, let us begin. First, general introduction. BIM is really a healthy disruption to a fragmented process. Building information modeling will allow engineers and architects to explore projects in greater depth than ever before. It simply replaces the sluggish and fragmented process with an interdisciplinary approach that consolidates effort. BIM is a life cycle information collection point for accessibility, and it focuses on saving resources, whether it is time, money, and material. And the more mature the model, the more advanced the model you create, the BIM model, the more useful information, the more savings, and the more benefits you will gain. Before we discuss the BIM concept and talk more about building information modeling, let's take a look at the computer-aided design and how CAD have gone through major changes over the course of time. Particularly significant in the construction industry is the evolution of 2D drafting into integrated BIM over the last 40 years. So the whole story began early 1960s when computer scientists and researchers started experimenting with mouse as an input device, and it took then about 10 years to see real application of CAD in a commercial mainframe. Then early in the 80s, with the personal computers, Apple II and PC, XP, and 80s, if you remember those PCs, commercial CAD was introduced on personal computers, and also later after that, we saw a lot of commercial 3D CAD in personal computers. Building information modeling really surfaced early 1990s with real success. Successful project completed using building information modeling or model concepts took place early 2000, where major projects were completed successfully using BIM concept or BIM platform. Now, 2011 and beyond, we will see real explosion of BIM in many areas and many by bringing in various stakeholders. Okay, next let's start by providing a simple definition of building information modeling, and then move on to more detailed definition and concept. First, building information modeling is simply the virtual building, if you like, or building simulation, where the actual building is digitally fully simulated in a computer model. A more precise definition is given by the National BIM Standard. So the National BIM Standard defines BIM or building information modeling utilize cutting-edge digital technology to establish computable representation of all the physical and functional characteristics of a facility or a structure, and it is intended to be a repository of information for the facility owner operator to use, maintain throughout the lifetime of the structure. Okay, here note that not all digital data is necessarily computable data, a distinction that at first glance may seem insignificant. A basic example would be a word processor and spreadsheet. So maybe I would like to give you this example. Let's say I created a table in a Word document where the first column is I'm going to consider a beam, a simple beam, is the distance from the left support. The second column is the intensity of loading at that specific location, and the third column would be the shear force for this. So I'm going to create the same table in a spreadsheet. So now I have two digital representations, but one is computable and the other is not. So for instance, if I change the intensity of loading at a specific location in that table, in the Word document, so nothing will happen. In other words, I have to manually change all the related fields, whereas in a spreadsheet, if I build all the formula correctly, if I change, for instance, the intensity of loading in one cell, in one location, in one field in the table, this will be reflected in all other fields. So that's clear that one is, both of them are digital, but one is computable and the second is not. So that is really the main difference between, the old concept and the new concept in construction. So in structural engineering, we know we really heavily depend on computing and calculations, and that's why the computable representation of the building is a key ingredient for us and also for the structural engineering workflow. So in the next slide, I will show you some key points of the BIM concept. So first, we know it is digital plus computable. It does include the entire life cycle from inception onward. All drawings are derived from a single model, and the model coordinates all the drawings, support collaboration, support interoperability using different data formats, and also it supports open standards and free data formats. So here are the main characteristics of the BIM concept. So the single file concept that includes the entire building, and the elements included in that model are real objects. They are not just drafting. So when you see a beam in BIM model, it's not a line. It is a real object. It's a real beam. It has a lot of content saved along with it. It does allow for changes of the model affect all related drawings and vice versa. We'll talk about that more later. And then estimating the generation and updating of all the necessary construction documents. And so far, up to now, we have really very rich architectural and structural library. And also mechanical, electrical, and plumbing libraries that will allow us to model many complex projects. And we know that a lot of information are attached to each element. And again, you have also the opportunity to define your own specific material if it is not in the commercially available library. Now, let's take a look at the tools that would allow us to implement those concepts of the BIM concept and creating a BIM model. So again here, after a number of surveys, most structural engineers use the following platforms to implement BIM. Revit structure is mostly widely used among structural engineers. And then we have Tekla structure, Bentley, and Archicad. So I will focus on Revit structure, give you a good foundation on that as well, because this will help us then, further discussing, the workflow and the interoperability next when we start talking about those issues. All right. Again, Revit is simply a platform for structural building information modeling. It's a design and documentation system that supports design, drawing, and coordination, scheduling required for a project. And there are a number of terms and terminology that you would need to acquaint yourself to when you work with Revit. And those terms, I'm going to go over them here a little bit quickly. One is the term of a project. Project is simply the single database file that hosts all the information about the project. And then we have level. Those are infinite horizontal plane that they act as a reference. And they normally host your like roof slab elements, and we use them to store it. And then we have element. Element is the key for Revit because those are the objects. So you will be, when we work BIM platform like Revit, you will be working with elements. So they are the objects. And those are classified by categories, families, types, and instances. I will explain that in the next slide. So very important here maybe to make decisions. So when you work with building information model, you will not be drafting, you will be modeling. And when you model, you will be working with elements and objects. So furthermore, those elements or objects are here classified in three main types: model elements, data elements, and view-specific elements. The model elements include beams, structural columns, footings, trusses, and so forth, and so on. And those are the models. We call them model components, and we have host components. So there's a little bit of a difference between those two. Maybe it would be also here important to get, so give you an idea about the elements and the grouping of the objects into the category, families, types, and units. So those are the 3-4 major classes. And then we say that all the elements belong to a hierarchy of classes. On the top of that is the category. And here, for instance, I give you a good example like column. Column is a category. And if I say the steel W shape is a family within the columns category, and if you say maybe the W10 by 49 is the type of the W-shaped family which belongs to the columns category, and so forth. So here we have also component families and system families. Component families, those are the families you will be able to build yourself, or you can add to the project. System family normally are systems that are not available for you, normally are included by default by that specific platform. So the views are windows to your project, and those include plan, elevation views, 3D sections, and many more. So there are also additional information that you could be able to define in your BIM model, like node combinations, different new materials, different quantities, different parametric information, different type of support, boundary conditions, and so forth. So next, I would like to take a look at the BIM-based workflow and contrast that with the traditional workflow in structural engineering practice. Let's begin with the traditional workflow. So normally, we receive drawings from our clients, architects, science, and then we start building our own models for different purposes, and then send that back to the architect, and then back and the drawings will be sent back and forth until a final conclusion is achieved, and then you create your construction document. Throughout this process, you will see that in structural engineering practice, this will result in multiple models that are not coordinated. So one of the major issues, in structural engineering practice, that you have to, or many times, you have to assign one of your highly educated or young engineers to spend much time creating those models and transfer data. For instance, you want to create a model for masonry design for connection. So from the architectural drawing, you will end up creating 3, 4, 5 different models to run specific computation for specific purposes, and then, if you want to do maybe something dynamic analysis and others, this will also require additional more time to create new models. So, and then let's assume that the architects and the client, they made some changes, then have to go back, and then each of those models manually, you need to adjust, correct, modify, and run your analysis again, and then send your feedback. So you get the idea how much time and how time intense and resources and money that is going to cost you in practice. Okay. In contrast to that, the BIM workflow or BIM-based workflow offers the following advantages. Board drawings are, driven from a single model, and the model is coherent and will coordinate all the drawings for you, so you don't need to spend too much time doing the coordination. And for instance, if you take a look at the model here on the right, you see the 3D, and you see the different views, framing elevation, framing plan, foundation plan. So if I make any changes, if I move the bracing or change the location of the shear wall here, I do it only once in one location. This will be then coordinated in all other views. So this is a huge saving. And then if I change the scale for one reason or another, this will be automatically taken care of through the system, through your BIM models. You don't spend too much time. Plus, you will see that there are a number of visualization rendering tools that will enhance the content for your clients and so forth. So in addition to those benefits, working from a single file, you'll be able to do a lot of other analysis which will enhance your model as well, like clash detection, which you cannot do in the traditional cost estimate. Again, you get it also easily done with the BIM approach and the coherency, and then that of course you will end up less errors, less omission, and better visualization. And of course, you can share this with your application and other subcontractors. Maybe at this point, I would like to give you maybe a more concrete example. Let's take the traditional approach. You have assigned one person, one engineer, to do framing elevation. Let's say 5 building framing elevation. And this will take, let's say, 1 day, which is 8 hours, at the rate of $20 an hour. So the total cost would be about $160, which is 20 times 8. And let's say in the BIM-based workflow, you assign the same person or one person to create those 5 framing elevation or building sections. It will take not more than 15 minutes, so that's a very conservative assumption. So 15 minutes, again, the rate is $20 per hour. Total cost will be $5. So your total saving will be $160 minus 5. So total saving will be $155. Multiplying that for all other design features such as framing plans, framing elevation, dimensioning, scheduling, section details, connection details, and so forth. This will add up to a huge saving at the end of the day. And so in summary, I would say 2 major key solutions that the BIM workflow will provide: interoperability and defragmentation. Interoperability will allow you through a neutral data format like the ISD, which is Industry Foundation Classes. Lisa will talk about that maybe more. So you would be able to, from a single data file or data model, you would be able to run different types of analysis. So masonry design, foundation design, connection design, and wood design, and other types, finite element, dynamic, and so forth and so on. Just working with single one model only, do things only once. And defragmentation will allow the model will allow you to share the model with all stakeholders participating in the project, like sustainable designer, environmental designer, facility operation, space assignment, landscape, and interior designers, maintenance repairs. So many uses for many purposes. All right. Next, let's examine how BIM can be implemented in structural engineering practice. So it doesn't matter whether you're an individual consultant or in a company interested in doing BIM on your own, irrespective of the other subcontractors you are working with, or you have BIM in a larger setting, a larger company where you have other subcontractors working with BIM as well. So as the individual consultant, you will be benefiting from the coordination that you will get with linking all your old 2D drawings, exporting your project to different software analysis without redoing or remodeling, and then also you can share the model to fabricator. Plus, you will be able to do flash detection, cost estimate, and also optimize your solution in a very efficient way. In the case of small, mid-sized companies, if you wanted to use that internally, in addition to the benefits mentioned before, you will be able to collaborate or divide big projects among team members, and then they can collaborate using the single BIM model. And then you could also collaborate with other disciplines within your firm, and also you can do flash detection, cost estimate, and many more. For the internal sharing, you'll be able to collaborate within your firm and also collaborate with other subcontractors you're working with. And here, really, you will gain the IPD benefits, which is the integrated project delivery approach. We'll talk about that in the next slides as well. So, in other words, for the collaboration and there are a number of methods you can achieve that by using the file server-based internal collaboration. And this could be achieved by creating a single file in a server, and then you can make copies, local copies for the different team members involved in the project, and then you should be able to assign workspaces or worksets. So it is a central file, contains a complete building, and then each team member will be working on a copy, and then the team member can send and regularly update the information to the centralized, database file. And the key here is to be able to logically and systematically define those worksets. And there are a number of ways to do that, as a matter of fact. So you can do this by saying, by storage or by maybe building types or structure system types. So for instance, masonry will be done by that team, and if you have a concrete or foundation, could be tackled by that team and so forth. All of those will be working from a single model. We'll update the model. Each party or each team can see the changes, regularly. So, the external sharing, you'll be able to, externally share the model using different data formats, using IFC, PDF, 3D, and many more. And in all those conditions, all the time, your structural model will be linked to the architecture, maybe also to MAB and others. And then all the analysis you will be doing will be reflected back to the architecture model. That way you get feedback as you are working in your structural model. So it will allow you to save time as well. All right, so in other words, using BIM is really about transforming the process of design and not just tools. And so as you can see here, this is the traditional approach. We know, and we talked about earlier. And then we have the IPD, or in other words, the BIM approach that will be explained a little bit more next. So we know the traditional approach you will end up in multiple models that are not coordinated, and each other documentation requires a huge amount of effort to coordinate and keep all those documentation and the construction document packages synchronized and up to date. And this will affect, as we know, efficiency, quality, flexibility, productivity, and cost. So in contrast to that, the building information modeling structural workflow uses only single model concept. And that single model integrates all the structural and all the physical representation. So all the both the physical representations and the structural model, coordinate, and the analytical presentation used for multiple structural analysis. So all of those would be derived from that single model. So the structural BIM offers a wide range of collaboration modes, as noted earlier. So you'd be able to import different export standard CAD files using bidirectional linking with other BIM or using virtual data format like ISD and others. So in the next slide, I will try here to show you again the differences between the traditional and the BIM workflow. So this is the IBD according to the architecture, the American Institute of Architects. So in the traditional workflow, which is characterized by segmentation, whereas in the IBD it is integrated and collaborative. Traditional approach is linear, sync, sequential, so each step has to be done before the other, whereas here in the IBD is concurrent and multi-level integration. The traditional paper-based, and here we have in the BIM model digitally based approach using BIM and 4D and beyond. So therefore, because of the differences between those two workflows, it is crucial to plan for the move from traditional to BIM workflow in a logical, symmetrical, and scalable manner. The next slide will try to address that. So the first thing, in a transitional, you need to create a transitional period where you want to experiment with one or two pilot projects that are typical to your practice, whether it is a commercial, you could do in commercial building, or your school, or just people residential buildings, for instance. Then you need to develop a BIM execution plan, and then you have to be also realistic in setting your goals. And for instance, you will, at the first, you would be interested maybe creating a BIM model that would be sufficient to run a static linear analysis successfully for the entire building. And then you can move on to a higher level of details for running more sophisticated type of analysis. But you start with the simplest. And then during that transition period, you definitely facilitate more discussion and then sharing knowledge and experiences. So another important step in that transitional period is the use of what we call the model progression specification. And here I would advise you to take a look at the AIA Digital Practice Guidelines, where we will see the level of detail required at each phase of the design, from conceptual design to fabrication and construction. So here we have level 100, 200, 300, 400. I will talk more about this in the next slide, give you a concrete example to clarify this a little bit more. So in that way, you need to establish this, so each member of the team know exactly what's supposed to be done and what level of detail they are looking or they are targeting. So this again, the full list of the level of detail according to the AIA Digital Practice Guidelines. Here I would like to give you a little bit more explanation of what I talked about the progression, model progression. Just take a look at the substructure foundation, for instance, the standard foundation. And these are the level of detail, LOD. So the level 100 means this is a conceptual. Let's say for a foundation, you need to figure out whether it is shallow or deep foundation. Design criteria here, maybe you decided to do shallow foundation, then you need to show at least the approximate size of the single footing, and then detailed design where you see all the reinforcements and the necessary data for the exact thicknesses and all the design criteria, and then after that, that's level 300, level 400, more details about the footing for the fabrication. Okay, and that's here more for the superstructure and different elements. There is a lot of lists for that. You can take a look at the IA digital guidelines. Okay, now, so in doing that, you need to establish your team. And in establishing your BIM team, you need to define roles and responsibilities. And this here is some suggestions, if you build your team from those called group 1, 2, BIM 1, 2, 3, and 4. So let's say here the role of the engineers will be creating the analytical model, make sure the analytical model is complete, defining all the loads, all the lateral and gravity systems, boundary conditions are defined, supports, and so forth, and then the model is ready for running analysis. In other words, sharing the model with a third-party software tool. And at the other side, at the end, principals and managers will make sure that the model is complete and satisfy all the design requirements before delivery. In other words, checking the integrity and completeness of the model. So you have to set all those in a kind of a checklist format. So that's why, say that you can also, in doing that, if you have a team, more than 2 or 3 engineers working, if the project is big or a little bit bigger, you can create a workspace that can be assigned to a specific number, a specific team members. And then you can create a link if that is needed for that transition project. Next, I would like to summarize the key features and benefits of implementing BIM in a structural engineering practice before inviting Lisa to address interoperability, legal, and contractual issues related to the BIM workflow. So I would say BIM represents the hub of software applications that streamline the delivery process of design, detailing, and implementation, detailing, manufacturing, and construction of our project. BIM gives structural firms an integrated modeling environment for design, analysis, and orientation. So all the structural design documentation are always coordinated, consistent, and complete. And not only computation, we also not only structural analysis and design computation. Also, we have the opportunity to do other type of analysis with the model, like collision detection, code checking, sustainable structures, and others. So there is no doubt in my mind that the collaborative mode will become will be the standard in the near future. So now, developing a transition plan is really helpful and important because you want to make the move in a very systematic and logical manner. You need to define team members' roles and responsibilities, a checklist of minimum model requirements using the IA foundation guidelines, digital guidelines will be very helpful. In other words, using the level of detail. You need to also create an independent checking of the model created, or examine that with your classical approach. And then, of course, you need to create a different review methods of the final deliverable. So, because you'll be reviewing a BIM model and not a paper. So, at the end, before I close, I would like to say that it is important to put in practice the standardized process, because BIM is not only a tool but an approach to the protection of construction information. It represents a shift away from the traditional approach. It is a change in process and culture that will provide a healthy and a successful environment for integrated construction engineering practice. And with this, the next slide will show you further information if you're interested. And then I would like to invite Lisa to continue with some of the benefits in the new, using the new workflow. Thank you.
Okay, so these slides here show the references for Dr. Nawari's part of the presentation. And I want to thank Dr. Nawari for co-presenting on this topic with me. My name is Lisa Willard. I'm with SE University, and it's part of a company called SE Solutions. And what I'm going to be focusing on this afternoon is looking at some of the interoperability, training, and legal issues with regards to BIM and structural engineering practice. Just an overview of the things that I'd like to cover today is first looking at interoperability from two different perspectives. First looking at it from the perspective of the design team, and Dr. Nawari went over that as well, but I'll be looking at some of the specific options for sharing that information. And then I'll also narrow in and focus specifically on interoperability for the structural engineering office. So how can you use some of your other programs along with the BIM modeling tools. We'll also talk about implementation and training just for a few minutes to expand a little bit on Dr. Nawari's BIM execution plan, looking at, maybe selecting champions for different software programs, looking at training and why that's important, and how you can find more information about the different programs and also training options. And then with the legal issues, unfortunately, it seems like over the last few years there's been many, many questions generated and not necessarily a lot of answers, but hopefully we'll be able to focus a little bit on, what are some of the issues that engineers do face with regards to legal and risk concerns, and where can you find some additional information about that. So starting off with the interoperability, again, looking at two different components. We'll be looking at interoperability for the design team, sharing information between disciplines, and then also focusing in and looking at what are your options for sharing a model between structural analysis and design software and sharing that information with the BIM modeling tool. With regards to the design team, there are a few different levels of sharing. There is the opportunity to specifically share CAD-type files. There's also the ability to link models together. So this would be, a higher level of sharing, of being able to get in further information and maintain that information throughout the project. And then also briefly looking at some of the copy monitor and interference checking tools.